We are live now.
Good afternoon, namaste, and a very warm welcome to all our distinguished speakers, delegates, and participants joining us for session 4 of TTDD 2026 titled HAPS Based Connectivity, Technical Feasibility, Trials, and Market Dynamics. I'm Vishali Uparwal. I'm working as a standards engineer at TSTSI. I'm the session coordinator for today's session, and it is my pleasure to welcome you all. Before we begin, I would like to share a few important hygiene announcements. These are also available in the chat window for your reference. All attendees will be kept on mute throughout the session by default. Kindly post your questions in the Q&A tab of the conference tool. These will be taken up during the Q&A session. Questions in the chat box will not be entertained. If you want to enlarge a presentation, please click on the expanding arrow icon at the top right of the presentation screen. The tool is configured for HD video. You may switch to LD in case you are facing bandwidth problems. Attendees may like to visit the exhibit booth of TSDSI in between the sessions to know more about our work. Attendees can use the launch facility for networking. The launch will remain open till the end of the conference. The conference sessions are being recorded and will be posted to the TTD website in the next few days. Now I would like to introduce our session convener, Mr. V.K. Roy. V.K. Roy is Advisor Networks at TSDSI. He served as Vice Chairman of ITUT Study Group 2 during 2022 to 2024. He has also made notable contributions towards international standards development through active participation in ITUR, ITUT 3GPP, and SOP for Bhutan's missions under ITUD sector. He contributed significantly as drafting member of Bharat 6G Vision document. Now it is my pleasure to introduce the co-chairs of the session. Mr. Abhijit Abhimanyu Masal is a principal research engineer at the Center of Excellence in Wireless Technology, Chennai, with over 12 years of experience in wireless standardization. He earned his MTech in Electronics and Communication Engineering from Indian Institute of Technology, Bhubaneswar in 2014. Mr. Suresh is a wireless networking professional and open source advocate with over a decade of experience in designing and deploying LTE, 5G, LPWAN, LowPAN, and UWP networks. A graduate of College of Engineering, he is the co-founder and chief technology officer of Susan Future Technologies Private Limited, where he focuses on developing sustainable technology solutions. With that, I now invite Mr. Abhijit Masal to take the session forward and introduce keynote speakers and handle the keynote segment. So the floor is yours.
Thank you, Vaishali. And hello, everyone. Very warm welcome for the session on HAPS-based connectivity and technical feasibility trial and market dynamics. So myself, Abhijit, as introduced by Vaishali. So it is my privilege to act as a chair for this particular session. So let's begin with creating some context for this particular session. As many of you know, roughly 1/3 of the population of the world's population still lack the connectivity, and even in a well-connected region, the delivering the coverage and in a difficult region or in a disaster zone, so it becomes it's still a stubborn challenge. And as we know, HAPS, which is high altitude platform stations, has emerged as a compiling answer to this particular gap to provide a ubiquitous coverage of a broadband services. So we know that base stations are on the ground, of course, right? So, but operating at a stratosphere around 20 kilometers high, well above the commercial aircrafts and weathers, these HAPS platforms are solar-powered aircrafts, airships, or balloons, which can act as a base stations from the sky, which is very fascinating, right? They promise a wide area coverage from a single platform, a low latency than the satellite communication, and the feasibility to be developed, and it has a feasibility to be deployed whenever and wherever it is the connectivity is necessary the most. to make to more. And what is very interesting in this particular moment in time is that HAPS is not just a laboratory concept anymore. With the dedicated spectrum allocation now in place, growing the standardization interest around the HAPS, and the series of real-time trials around the world, the technology is actually moving steadily from validation to towards or feasibility, from feasibility towards the viability. And also in 6G, HAPS is increasingly seen as not a competitor, but also as a complementary technology to the terrestrial and satellite communication. So our aim today is to bring together the two conversations generally happens in the separate room, right? Which is technically and strategical. So on technical side, our esteemed speakers, which for today's session will have a walkthrough, a feasibility study, early test, and the result. Whereas on the strategic side, our panel discussion, which will be followed from the keynotes, initial keynotes, 3 keynotes, will discuss about the strategy side, uh, pertaining to the market dynamics, regulatory frameworks, and also dedicated interplay between the innovation and the market adaptation. So by holding both the conversation together, what we are trying to do within this particular session is to give a full picture or a fuller and more grounded picture about where the HAPS is heading, and what is the next possibility in this particular domain. So with that, I'm very delighted that we have got a very calibered speaker today joining us. Uh, uh, the speakers are actually involved, are from the voices from the industry, research institutes, also from the telecom operators. So I sincerely thank each of the speakers for kindly accepting our invitation and making time to share their insight and experience with us. Their willingness to be here itself is a great gift for our community here. So with that, as we can see on the screen, this is the session plan. So we have 3 keynote speakers, followed by a panel discussion. So I would like to go to the first keynote speaker now. So let me invite the first keynote speaker, uh, Mr. Kantaro Sakata from SoftBank. So before I hand over to Mr. Sakata, I just read out his bio. So Mr. Sakata has been actively engaged in international standardization activity in ITUR and APT as a member of Japanese delegation. He has contributed to the spectrum-related discussions and the terrestrial systems, including the IMT and HAPS, and developed the IMT 2030 6G radio interfaces. He contributed to the identification of HAPS band, particularly 700 and 900 megahertz and 1.7 to 2.1 gigahertz band, and also 26 gigahertz band in WRC 23 under the agenda item 1.4. He is also involved in IMT ITUR WP5D activities towards IMT 2030 minimum technical performance requirement, which just completed by ITUR, particularly on the resilience and extended connectivity, which is very focused on the HAPS and HIPS kind of technologies. So with this, I kindly invite Dr. Sakata, to present his keynote. Over to you, Dr. Sakata.
Yes. Thank you, Dr. Mazar. And yeah, good afternoon, everyone. Namaste. My name is Kentaro Sakata from SoftBank. So as Dr. Mazar kindly introduced me, I'm mainly in charge of the standardization activity in ITUR related to the terrestrial systems, including HAPS and HIBS. So today I'd like to talk about NTN and HAPS towards the 6G era. In my presentation, I will first explain why non-terrestrial networks are becoming increasingly important. Then I will introduce the role of HAPS, its regulatory standardization status, and finally our activity towards the HAPS technology development and commercialization. Yeah. So first, let us think about the critical lifeline in modern society. Traditionally, when we talk about lifeline, we think of water, electricity, and gas. So these are essential infrastructure that support our daily lives, our economy, and public safety. Without them, modern society cannot function properly. So next page, please. Yeah, so today mobile communication has also become a critical lifeline. People rely on mobile network not only for personal communication, but also for work, education, disaster response, and access to public services. So from my perspective, mobile connectivity should now be regarded as one of the essential infrastructures of society together with water, electricity, and gas. So this point is especially important because expansion for mobile network are no longer limited to convenience. So in many situations, connectivity is directly linked to safety, inclusion, and continuity of social activities. So next slide, please. Yeah, so mobile network operators, our MNOs, have developed many types of ground-based infrastructure to create coverage. For example, we use tower site for wide area coverage, a rooftop site in dense urban areas, and a concrete pole for flexible deployment, and indoor systems for buildings. In other words, terrestrial mobile networks are already highly optimized. But there are still areas where terrestrial deployment is technically or economically difficult. So this is why the discussion is not about replacing the existing terrestrial network. The starting point is to recognize how strong the terrestrial network already is, and then to identify where an additional layer can complement it. So next slide, please. So this slide shows the limitation of the conventional ground coverage method. So in these urban areas, we can usually deploy enough base station, but in rural, super rural, mountains, island, maritime, and aeronautical areas, terrestrial coverage become much more difficult. So this issue is not only technical, it is also related to cost, backhaul, and power supply. So rural and remote coverage remains an important challenge. So next slide, please. Yeah. So in addition to coverage, resilience is becoming more a serious issue. So natural disasters are increasing in scale and impact, as you know. So during disasters, terrestrial base stations, backhaul link, and power supply may be damaged. In such situations, communication is essential for rescue, safety confirmation, and recovery operations. So it is also important for local governments and emergency teams to understand the situation on the ground and allocate resource and communicate instruction to affected communities. So the question is, how can we maintain or rapidly restore connectivity when ground infrastructure is disrupted? Next slide, please. So this is where NTN becomes important. So NTN provides connectivity from the sky beyond conventional ground-based coverage. It can complement terrestrial networks by providing wide area and resilient coverage. NTN includes different types of platforms, such as satellites and HAPS. The key point is that NTN is not a replacement for terrestrial network. It is an additional network layer. In other words, the future architecture is not a simple choice between ground and sky. It is a combination of layers where each layer is used in the area where it has the strongest advantage. Next page, please. So connectivity is needed for everything, everywhere, and at all times. There are three important use cases. First, bridging the digital divide in rural and developing countries. This is about giving people across the basic digital services, education, healthcare information, and economic opportunities. Second, seamless connectivity even during disasters. And the third one is 3D coverage, including connectivity in the sky for drones and aircraft. So these use cases are strongly aligned with the future direction of 6G. Next slide, please. Yes. So this slide shows the 6G framework in ITUR. So as shown in this slide, NTN-related elements, this is very important, are included in the official IMT 2030 concept. So that is a very important because NTN is no longer just an operational enhancement. It is becoming part of the fundamental 6G concept. Next slide, please. Yes. So this slide shows the IMT 2030 technical performance requirement, TPRs. In the ITR Working Party 5D February meeting this year, these TPR for IMT 2030 were effectively decided. Among them, I'd like to highlight the new requirement called resilience and extended connectivity that supports ubiquitous connectivity usage scenario. So compared with previous generation, this shows a broader view of mobile performance. It is not only about peak data rate or latency, but also about whether connectivity can reach difficult areas and continue under emergency situations. So this requirement is very relevant to NTN, especially high altitude platform station. So next slide, please. So here, resilience means that the networks and systems should continue operating correctly during and after service disruption. And extended connectivity means providing connectivity in areas that are currently uncovered or scarcely covered due to geographical condition or lack of infrastructure. And this concept directly corresponding to main entity use cases such as disaster recovery, rural coverage, and 3G coverage. For this reason, HAPS can be positioned very naturally within the 6G discussion. So it addresses both continuity of services and expansion of service area. So from a 6G perspective, NTN and HAPS are very important solution to meet these new requirements. Next slide, please. Yeah, this slide shows the overall structure of NTN. In general, NTN includes three types of solutions, HAPS, LEO, and geosatellites. So each solution has different characteristics, and each can play a different role in the future mobile networks. The difference in altitude is very important because altitude directly affected the coverage size, link budget, latency, and type of services that can be efficiently provided. Next page, please. Yeah, with respect to HAPS, it operates at around 20 kilometers in the stratosphere, and the atmosphere relatively stable atmospheric condition compared with the lower atmosphere. From this altitude, one HAPS can potentially cover a very wide area around 200 kilometers in diameter. At the same time, a HAPS is much closer to user than satellites, which is one reason why it is attractive for mobile direct communication and for use cases that require relatively good penetration and capacity for HAPS. Next, please. From a functional perspective, HAPS is regarded as an end-to-end solution. It provides satellite-like functionality such as a wide area coverage and just a resilient connectivity. But from the regulatory perspective of the ITU radio regulation, RR, HAPS is categorized under terrestrial radio communication services. So simply speaking, HAPS is functionally NTN-like. But from regulatory perspective, it is treated as a part of the terrestrial networks. So this discussion is important for understanding how HAPS can be introduced under existing mobile regulatory concepts. Next slide, please. As shown in resilience and connectivity definition, which is in TPR of IMT 2030, HAPS as IMT base station called HIBS is listed as one of the key technology to meet this requirement. So this is a very important achievement for HAPS because it shows that the HAPS is recognized not only as experimental platform, but enabling technology for future IT systems. So maybe someone, thank you. So next page, please. So someone echo.
Sorry. Sorry.
Could
There
you-
is somebody I think has switched on the mic. Can we just
could
switch
you-
off the mic and the speaker can speak? There is a echo.
Could you meet?
Yeah.
Oh,
Go ahead.
that's good.
Thank
Thank
you.
you. Thank you very much. Yeah. So spectrum is one of the most important issues for HAPS commercialization. This slide shows spectrum bands already identified in the ITR regulation. For HIBS service link, several IT bands are identified, including 700, 1.7 to 2.1 GHz, and 2.6 GHz bands. The service link is connected to user, so ecosystem capability is crucial. And for HAPS feeder links in the fixed services, several higher frequency bands are identified, such as 38 to 39.5 GHz and 47 GHz bands. So the feeder link is the connection between HAPS platform and the ground network. So capacity, and reliable backhaul design are key considerations. Next slide, please. Yes. So 3GPP specifications are also important for HAPS commercialization. So key point is that HIBs can be used within the existing IMT concept in the band such as 700 MHz, 1.7 to 2.1 GHz, and 2.6 GHz band, which is a global band for mobile systems. So this matters because we need compatibility with the existing wide ecosystem. If other mobile devices and standardized network equipment can be used as much as possible, the path toward deployment becomes much more realistic for HAPS. Next slide, please. So this slide compares end-to-end solution for D2D communication. So LEO satellites can provide ultra-wide coverage, but they're much further away. And the HAPS is positioned between terrestrial networks and LEO satellites. It can provide terrestrial networks and LEO. It can provide wide coverage, relatively lower latency and higher capacity than satellite in specific areas, and better penetration characteristics. So the important point is not to choose one solution. We should capitalize on the unique characteristics of each layer. For example, LEO may be very effective for broad area basic connectivity, while HAPS can be suitable when we want to focus capacity over a particular region or support disaster recovery with stronger local coverage. Next, please. So this slide illustrates the service territory of each solution. So ground networks are best for dense capacity and rich services, and the HIPS can extend mobile band-like services to wider or more difficult areas. And the LEO can provide basic connectivity over ultra-wide areas. In practical terms, users should not need to care which layer is serving them. So objective is to make the new experience as seamless as possible across terrestrial HAPS and satellite layers. So next slide, please. This slide shows an example of NTN in disaster situation. The key message is that NTN is resilient because it is independent from damaged ground infrastructure. And among NTN options, HAPS can be powerful where penetration, capacity, and quick deployment are important and necessary. And in a disaster area, different communication needs at the same time, such as simply safety confirmation, both voice communication for coordination, and the higher capacity links such as video and video for medical and rescue support. So a layered end-to-end approach can help address these needs more flexibility. So next slide, please. And now I'd like to introduce our HAPS activities. So this slide shows our fixed-wing HAPS type platform development. So the platform has reached the stratosphere multiple times since 2020, named Sunglider. So these flight experiences are very important for validating the aircraft design and the power management, payload flight control, and the stratospheric operation. So next, please. And now we are also accelerating the realization of the next generation networks using airship type platforms performed by Sky. Airship type HAPS platforms are expected to stay in the stratosphere for long durations. So this is attractive for communication services because long durations are essential for stable services. Next slide, please. So there are two major types of HAPS platform. One is heavier than air, HTA. So this includes fixed-wing aircraft such as Sunglider. The other one is lighter than the air, LTA. So this includes airship type platforms such as Sky. A common question is, which is better? My answer is one is not simply better than other one. So HTA and LTA have different strengths. HTA may be stable in keeping station, and LTA may be attractive for a long duration. Therefore, platform selection should depend on the service scenario, required payload, operational model, and deployment timeline. So in this sense, diversity of platform is a strength for the HAPS ecosystem. Next, please. So this slide shows our roadmap for pre-commercial services from 2026. For LTA, SoftBank is targeting the limited service for disaster recovery from this year in Japan. From 2027 or later, the scope may expand it to regular communications. For HTA, commercial services are indicated for 2029 or later. So this step-by-step approach is important, starting from limited use cases, enable technical validation, regulatory coordination, and operational learning before a broader commercial deployment. Next, please. So Japan completed its domestic regulatory framework for HAPS services in May this year, enabling this year's our pre-commercial launch. For service link, 2.1 GHz band is used, and HAPS is defined as a high altitude base station in the land mobile service, which is a new station category. For the feeder link, 38 to 39.5 GHz band is used in the fixed service. The framework also defines technical requirements, operational areas, and installation location concepts. This is a significant milestone because commercial technology development cannot move forward without a clear licensing and operational framework. So regulation, standardization, and technology must progress together. Next, please. And HAPS cannot be realized by one company alone. The HAPS Alliance is an industry entity to build such an ecosystem. So this cross-industry approach is very important because HAPS is both aviation and telecommunication systems. It requires cooperation among aircraft developers, telecom operators, vendors, regulators, and academia. Next, please. So HAPS is also discussed in ITU-D, development sector of ITU. In a recent ITU-D discussion at WTDC 25 last year, HAPS has been recognized as one of the efficient solutions for rural and remote areas and for emergency and disaster solutions. And this is meaningful because it concepts HAPS not only with advanced 6G technology, but also with broader social objectives such as digital inclusion and disaster preparedness. Next slide, please. In the Asia-Pacific region, including Japan and India, APT Wireless Group, AWG, is also working on HAPS-related study, which address information on industry and ecosystem and technical and operational analysis of HAPS. These reports are useful for administration and industry players in this region, including countries considering a future HAPS introduction. So regional discussion is important because HAPS development will require harmonized understanding of spectrum operation and coexistence with existing systems. So next page, please. So to summarize my presentation, the future network will not be only terrestrial, only HAPS, or only satellite. It will be integrated and multiple layer network. So this is one of the important discussion and the direction and discussion towards the 6G era. Among these solutions, HAPS will provide a wide area and resident coverage from the stratosphere with high capacity, low latency, and good penetration. Next page, please. So this is a final slide. So then the HAPS can play a bridging role between strong terrestrial networks and wide satellite coverage. By combining these layers, we can move close to a world where connectivity is available everywhere during normal times and also in emergencies. So that's all for my presentation. Thank you very much for your attention. Thank you.
Thank you, Mr. Sakata, for a very enriching presentation on the HAPS, the trials, the activities that is happening from the SoftBank. I think you rightly bring out some points like the HAPS or NTN cannot be seen as a competitor to each other or with the terrestrial network. Rather, it becomes very complementary to each other for future networks. And also, as you rightly pointed out, the mobile network are no more just merely a convenience nowadays, but it is become an essential part of our or has become as a commodity where it becomes an essential part of a day-to-day life. With that, having a good coverage and a multi-layered network is an essential part. And going ahead, HAPS, the satellite and as well as terrestrial networks will work very closely to each other. Also, interestingly, you gave a light on the different platforms that SoftBank is looking for from the commercial triad point of view. Also, you brought out some aspects on the commercialization, which is very good, very enriching. Thank you very much for this. I would like the participants to have questions on the Q&A session. So what we have planned is we will take the questions at the end of the session after the panel discussion. So you can point out your question particular to a particular, if you have a question to a particular speaker, please write down that along with your question. So thank you very much. Then let's move to the next keynote by Dr. Animesh Yadav. He is an assistant professor at Electrical Engineering and Computer Science, Ohio University, USA. Before academia, he spent 5 years in industry developing WiMAX-based wireless networks. His research focuses on interaction of communication, computing, and networks with emphasis on machine learning for wireless systems, integrated terrestrial and non-terrestrial networks, integrated sensing and communication, and reconfiguration surface. So Dr. Yadav is IEEE member and is an editor, senior editor in IEEE Communication Letters, associate editor in the Frontier of Communication and Networks. He received his master's from IIT Roorkee in India and his doctorate from University Oulu, Finland. Over to you, Dr. Animesh.
Yeah, thank you, Abhijit. Let me share my screen with you all. Yeah, Abhijit, yeah, okay, now I can do that. I hope all of you can see my screen.
Yeah, it's visible. Go ahead, sir.
Okay, thank you. Thank you, Abhijit, for this nice introduction. And thank you for inviting me also. And hello and namaste to all. Greetings from Ohio. So in this talk, I'll be talking briefly about or put my view forward about an academic perspective of HAPS, especially on the communication related services, how HAPS can benefit 6G and beyond networks, and what are the opportunities and challenges we see. So first of all, I'd like to start with the motivation why there is a need for HAPS, and then I will highlight some of research activities that is happening in my group. So let us start to look at the 6G key capabilities built on the IMT 2030 framework that ITU first published in December 2023 as a globally harmonized foundation for next generation connectivity. So, these are also the capabilities for 5G, but here you can see that there is an ultra in front of every capabilities. For example, ultra high data rate, ultra low latency, ultra high reliability, ultra dense connectivity, sustainability, mobility, spectrum efficiency, and coverage. So these are the things that supposed to be in 6G, and we have to have some ways to address all these things. So some of the capabilities can be addressed, can be achieved by expanding, for example, expanding network coverage both in the air and remote region, and increasing connection density both in the air and urban regions. So when I say in the air, it means that I'm talking about 3D connectivity and 3D coverage because of services provided by drones and cargo drones, such as taxis and so on. So we also need connectivity for and coverage for them. So this can be done by simply terrestrial cell densification, at least on the terrestrial level. But increasing these many terrestrial cells will leads to significant investment and resources, operational and investment. All these for erecting these many base stations would be very high. So having such a high number of base station to achieve things might not be favorable to us in way that the handover may not be seamless. For in the case of mobility, the network sustainability will be uncertain because 6G is also talking about such sustainable networks, and also 3D coverage and connectivity are likely to be unreliable just by having terrestrial cells. So capacity, coverage, connection, reliability, sustainability, and mobility must be addressed together to meet IMT 2030 key capabilities. And how do we do that? So the solution that I see is having a multi-tiered 6G networks. So when I say multi-tiered, it means that we have to integrate terrestrial network with the non-terrestrial network. Like in the previous keynote, Mr. Keynote speaker has pointed out that we have to connect space network, aerial network with the ground network. So space network generally have satellites both in GEO, LEO, and MEO, but there is an addition of aerial network which has a HAPS into it. And my talk will be focused on especially integrating HAPS and the terrestrial network today. Although I'm working on all three, integrating all three network layer, but today I'll be just focusing on HAPS network and ground networks. So with these three network, integrated, we can achieve, provide broadband connection to rural homes. It will provide a complete, reliable mobile coverage, and also urban region, because urban region going to have a high density of users and they need high capacity. And so this can HAPS can able to provide that also, not just for the rural or bridging the digital divide, but is also help us to solve the problems which are in the urban regions. So let us look at from a different height or altitude perspective how the where the HAPS is positioned. So here the HAPS, which is at a 18 to 22 kilometer in the stratosphere, and which will be on a special emphasis here in this talk as a network infrastructure because of its unique position. Let us look at how ITU defines HAPS. So this is the text proposed by Wireless World Research Forum, and it says that with its bird eyes and almost line of sight view of the entire metropolitan area, and HAPS is more than a base station in the air. It is a new architecture paradigm with access transport and core network functionality for integrated connectivity, computing, sensing, positioning, and navigation towards enabling a variety of use cases in an agile and green manner for smart and sustainable society of the future. So here we see that also ITU also recognized their the potential of HAPS as a flying base station or a flying macro base station. With this, let us look at some of the key characteristic of HAPS that makes it or helps some of us, those who are here, to recognize that what is the potential of HAPS and why we should invest in HAPS. It provides a favorable channel condition, line of sight links with high probability from stratosphere to the ground users, and the path loss is same as the microcell of radius 2 kilometers. And some of the HAPs are, like the BLIM type of HAP, they are almost geostationary, and you cannot see any Doppler shift in those. Although there would be some jitter, but not much. They have a large footprint, almost covering the area of 200 kilometer radius. They are a large platform also. So large platform also help us to deploy massive MIMO and full duplex transceiver. There is a problem with the full duplex transceiver, if you remember, like the transmitter and the receiver, if you put it next to each other, there will be self-interference. But if because of the large platform, we can put the two transmitter and the receiver far away, so we can at least achieve the passive, self-interference cancellation, which is very good in HAPS. So we can do, we can improve the spectral efficiency in that case. There's low latency. This low latency, at least it is compared to satellites. And also it will provide, a hybrid connectivity because cellular and FSO-based bands. HAPS is also known as HIPS from IQ terminology. So let us look at, what it covers. It is almost covering the entire city or larger than the whole city, and it can able to provide so many services at the same time. And there are some, I have listed some of them here, but if you look at a few things, for example, cost reduction. We do not to have so many base stations. We can have just one HAPS in the stratosphere. In that way, we can able to reduce cost. There is no need to worry about weather, because stratosphere is basically weather resilient. So we don't have to worry about anything. Whatever the weather conditions are there only on the Earth's lower atmosphere where we live. So if any disaster happens, so HAPS is still there working, and we can able to use it for many other purposes. And also, like since it is flying up in the air and all the time the sun is there, as long as the sun is there, HAPS can able to harvest energy from sunlight, and then can continue work on it using that power. Because there is no cloud and anything like that that hinders sunlight coming to it. So this makes HAPS very, very promising solution for at least in that stratosphere region, the network infrastructure that can help us to improve our connectivity. So HAPS comes with various shapes and sizes. I'll show you some of them here. The blimp shape, the fixed wing rotatory, and these are the few shapes that I have found and I've seen. So this one is from SCI, which is based in US. The company which is based in, so this one SCI. So every layer of network has infrastructure has its own value for connectivity. For example, satellites have their own services, and so as anything that is on the Earth's surface, and also HAPS will also has their own way to contribute to these services. Like, for example, it will provide flexible, scalable, cost-effective, wide coverage, and direct-to-cell phone type of services. So idea is here is not to replace either of the already existing one, like terrestrial base station or satellites. Idea here is to complement these already existing technologies, and that's where we can progress. So HAPS is here for complementing, not competing. And that is also my viewpoint and the HAPS should be used in this way. So so now let us look at what we are doing in HAPS related research in my lab. So we have identified some of the potential research direction that HAPS can offer to us. So in this, there are 6 potential directions. Like, it can help us to have an intelligent transportation system. It can also be aided with reconfigurable intelligent surfaces and relay to provide further coverage. It can be, work as a base station, a flying base station, as HIPS. It can be also used for computing and caching as an edge computer. It can be also used for sensing and communication, and also be used for localization, positioning, and navigation. So I will list a few of them here, not everything. So as I go, I will provide you a couple of use cases where these potential research directions has been used. Before that, let me show you a case study done by us. And in this case study is we will show you that how HAPS can able to provide a sustainable network. So in this case, whenever some users which are not able to connect to the base stations because of either they are out of their range or they are fully overloaded, so they're not able to connect. So we can to provide coverage to them. So we have to add additional base station to provide services to them. And earlier it was 36 original base station. As the user increases, now we have to add additional 49 base station to provide services to them, especially to the rejected user. But this can be done just by only having one HAPS. And in that case, we have seen that the network capacity utilization, when we have used HAPS assisted network, it was went from we have got 71.2%, and with the densified terrestrial network, it was 31.3%. And in terms of power consumption, you can see that we have just able to use 140.6 kilowatt. On the other hand, dense terrestrial network was consuming 314.5 kilowatt. So here we can see that just having one HAPS, we can save a lot of power consumption. So it does provide a sustainable network. And this will be even better, even more. This numbers will be better when we have even more amount of HAPS and users. So let's talk about use case number one. HAPS for 3D aerial highways. So in future, we'll be going to have a massive amount of cargo UAVs in both in rural and urban areas, which is expected to generate high income for several HAPS-based applications such as aerial delivery, aerial taxis, intelligent transportation services. Owing to these capabilities, HAPS system can act as an adequate cellular connectivity platform for cargo UAVs traveling in 3D aerial highways. Since HAPS can guarantee reliable wide coverage with relatively low latency, especially in densely populated areas where thousands of cargo AVs are expected to be flying around daily. So we can see there is a good use case for HAPS here to provide the continuous connectivity for all these flying objects in the air. Second is about beyond cell communication. In this case, generally what happens whenever the cell is fully loaded, so the users cannot be admitted into that cell, even though are in the same cell. So for example, here the red cells are in the coverage area of the cell, but cannot be served because the base stations are fully loaded. So here, what we said, so we can say that these users can be served beyond cell. So what I mean that if we have an RIS aided HAPS, so these rejected users in red color can be served through another base station or control station but by reflecting the signals from the RIS, which is at the belly of the HAPS, to these users. And that's what we call it as a beyond cell communication, because now they're communicating not, which is earlier confined, the communication is confined within the cell, but now it is going beyond the cell. So this is what we have proposed. And in third case, we can also do the federated learning in stratosphere. So in this case, if the FL server is located in the base station, the idea is that base station, the FL server at the HAPS can see a large amount of users, and these large amount of users will help us to improve the learning, because they can now able to see, not see, at least able to access a lot of databases, better learning, and and these can just communicate directly to one-shot learning at HAPS. So this we have seen that there is a very large improvement in the learning process when HAPS has able to access to large amount of clients. Although there is an issue with it, because large amount of client, there is also possibilities that all these clients do not have an IID data. They are going to have a non-IID data. So now we are also working on another paper, which is where we have tackling the non-IIDness when HAPS able to see large amount of data. Another use cases, which is handling interference, and because HAPS able to see, it has a large coverage, it can able to see large amount of users and base stations. So interference would be a big problem, because if HAPS and the base stations, macro base station on the ground, they're working on harmonized network. So any signal coming from HAPS will also be heard by the user, which is served by the terrestrial base station. So how to handle these type of interference? And this interference will get even worse when the number of users and base station increases, and which is very natural for HAPS, because HAPS has a wide coverage area. So this is a big problem for us. So we are also looking into this, how to handle interference in a large network. So we proposed an algorithm where HAPS can able to manage interference especially for the large scale HAPS network. And this paper, we have just got acceptance on this paper. So with this, I will. These are the things that we have done, and there are few things like already we are working on. So one of them is integrated sensing and communication, where HAPS can provide communication to the ground user as well as to any flying taxis or flying cargo drones. And the idea is that it can use sensing to find out their location, 3D location, and then communicate. So same signal can be used for communication, but like one signal, if it is used for communication to this vehicle over here, the same signal can be reflected back from a flying taxis, which can be used for finding out its 3D location. And when it is 3D location is found out, it can communicate to those that cargo drone or flying taxis. So, and we are also working on because HAPS also have some kind of jitter, and this jitter will be a problematic for beam if we are working with a very narrow beam. So the beam misalignment would be an issue. And also this beam of pointing error in the case of free space optical links, if there is a mismatch between the transmitter and the receiver. So we are also working on those areas to see how we can make this thing possible. So with this, I'll stop, and if there is any question, please let me know.
Thank you very much, Dr. Animesh. Thank you for bringing out the academic perspective on the HAPS or HIPS platforms. And you nicely bring out some aspects on the present study or the research that is being carried out, and on the HAPS related HAP related activities, especially on sensing, computing, and cache, ITS, RIS, and the localization point of view, which are a good services or the features that we can see from the HAPS. And also you nicely bring it out why HAPS is more feasible in terms of sustainability by considering a particular case study from your point of view. So thank you very much for those insights and details and the future studies or the research directions that one can think from the HAPS point of view. Thank you very much, Dr. Animesh.
Yeah, thank you.
Thank you. So with that, we will go to our next keynote. So next keynote is by Mr. Prafulla Kumar. He is Vice President C Head of Technology and Product SATCOM in Reliance Jio, where he leads the strategy, technology, and spectrum and product initiatives for LEO, for GSO and NGSO satellite communication networks. With over 20 years of experience in satellite communication, spectrum management, and orbit resource planning, he has played a key role in satellite and ground segment deployments and frequency coordination and the spectrum policies. Prior to Geo, he spent around 15 years in Indian Space Research Organization, ISRO, contributing to satellite payload planning, HTS gateway realization, IQR engagements. He is widely recognized in his expertise in satellite telecommunications, spectrum coexistence, and next generation satellite connectivity for sea digital transformation. Over to you, Prafulla.
Yeah, thank you so much, Abhijit. Am I audible? Can you confirm?
Yes, you are loud and clear. Please go ahead.
Okay, thank you so much, and good afternoon, good evening to everyone. So I think we have already heard two very great and important presentation on HAPS. So I am focusing in my presentation towards HAPS technology demonstration to how to make it sustainable commercial deployment, and would like to highlight what is happening today and what are the still points open which need to be addressed to make it commercial viable as a middle layer connectivity solution. My presentation would be towards that. And there may be one or two slides overlapping with the previous presentation. So I'll like to only leave the key messages and not expending much time on that. So with this, can we go to the next slide, please? Yeah, so this slide explain about a overall technology insight of HAPS and where HAPS fit best. So HAPS generally operates in the stratosphere around 20 kilometer above Earth surface. And this technology is focused towards the persistence and localized footprint, which is stable. And the important part is this is already part of NTN framework and 3GPP. So if we see today in the communication, already we have a terrestrial connectivity, and then as a part of NTN, there is a satellite connectivity. So if we see in the diagram, the satellite connectivity where the satellite operates in LEO, MEO, and GEO, and generally have a global type of coverage against the terrestrial, which is generally a localized coverage in 3 to 5 kilometer of radius. But there are areas, for example, suburb or even rural, where either terrestrial or satellite may not be the best technology to use. And this is where the HAPS fits as a middle layer of connectivity, which today in terms of connectivity solution, probably it is missing. So HAPS is going to bridge the gap between the coverage of terrestrial network and the satellite constellation, much like a satellite, but at a very lower height. The value proposition for HAPS is probably in terms of, if we see the characteristic, it's low latency. It's a similar to the fiber scenario or terrestrial scenario. And it might be required a lower deployment cost than the large constellation, because the constellation will have a global coverage, and HAPS is still will have a localized coverage based on the requirement. And the important part, which probably we need to understand about HAPS, in terms of the application, it is not only limited to connectivity solution, but it also provide the other important application, for example, a continuous monitoring or imaging in the areas which are critically important with respect to the defense application or anything. So important point is we can probably swap the payload. We can have few HAPS with the telecom payload, but few HAPS could be with the other payload like sensor or optical imaging. So this is one flexibility which is easy for HAPS, which is not possible for satellite, because once you launch the satellite, you cannot bring back and change the payload or swap the payload. You have to have a different payload, a different spacecraft for that. And another important point probably is the zero orbital debris risk, which is now being talked so much because of the thousands of satellites already in the orbit. And in terms of the use case, if we see, as I mentioned, the connectivity is one part, of course, where the D2D and other type of connectivity it can have. Then it can also help in the disaster recovery, Earth observation, as I just mentioned about the imaging and monitoring using the different sensor. Then the border security and the defense application, and as well as the persistence surveillance. So this is where the HAPS fit with respect to the use cases and the value proposition. And as a platform, once we talk about HAPS as a connectivity, then that alternative terms are being used as per ITU is a HIPS, which is a HAPS IMT base station, which is generally used for the connectivity directly to mobile handset. Can you please go to next slide? Yeah. So HAPS actually, why it is needed and where does it fit? So first of all, it's not a replacement technology to terrestrial or satellite, but it is going to complement between the terrestrial and satellite as a middle layer of connectivity. So today we have a connectivity solution, but where is the challenge and why the HAPS is needed? So today, if we see in the ground network, the terrestrial network or IMT base station is excellent for the dense urban, even in rural with better population, where it makes sense to lay the fiber and it is economically viable. However, it may not be technically feasible or commercially viable when we want to serve a very less population in the super rural areas, or if we need to have a connectivity in the coastal region or maritime water. So these are the few gaps with the today's technology. So how we can bridge it is the integrate NTN along with the TN, so that to cover those super rural and maritime. So we have a already a solution like satellite, which can of course meet entire coverage requirement irrespective of the place or location. However, this has its own limitation, which anyway I will highlight in which is I explained in the table. So the other alternate technology is HAPS to meet those coverage gap, and it can be economically make it those connectivity possible. So if we compare these three technology or these three connectivity solution with respect to the coverage, capacity, latency, deployment, so where it does fit it? If we see the coverage, of course, fiber has a specific coverage and where it is economically viable, but the satellite has excellent global coverage. In terms of the capacity, if we see the fiber, of course, offer a Gbps or very high capacity per square kilometer. However, satellite lacks there because of the limited spectrum and the technology, and to close the link budget, a lower spectral efficiency. However, HAPS fit in between the fiber and satellite in this case. In case of rapid deployment and disaster recovery, probably the terrestrial connectivity is not the best way to connect. And this is where the HAPS best fit, which can be easily and quickly deploy, and it has an excellent disaster recovery. And in terms of the latency, it has a low latency compared to satellite and on par with the terrestrial. So if we summarize about where it is fitting properly, so wherever the target efficiency for a specific reason is needed, where fiber is not a great solution to connect because of the economics, that's the where the HAPS can fit very well. Second is it has a superior D2D and low latency broadband connectivity. Why superior D2D? Because if we see the satellite is another technology where the D2D are being discussed. However, still because of the physics, it has a good service or use cases for SMS and low rate of data or even voice. However, HAPS can even provide a few tens of Mbps to each user device because of the link budget and the altitude at 20 kilometer or lower path loss. It has a better indoor penetration or connectivity. Today, if we see the satellite is needed a clear line of sight, even when we are trying to connect the mobile devices for the D2D, it doesn't have a sufficient signal to penetrate inside or indoor. So this is where HAPS is going to play a major role. So overall, it complements ground plus satellite system to extend coverage and add resiliency if we need to explain how HAPS is going to fit. So now if we see in terms of the technology, HAPS is no longer as a aircraft project now. It is becoming a part of NTN ecosystem as already put in the agenda of 6G IMT vision. So this is where HAPS is becoming now more important, or being talked to have or bring it in the mainstream for connectivity. Can we go to next slide, please? Yeah. So in terms of platform architecture, I'll not spend much time. This already our previous speaker Sakata and Animes has already explained. So there are two type of platform. One is HTA, heavier than air, and then the lighter than air. Both has their own advantage, disadvantage. For example, in terms of the fixed wing, it has a challenge of having a large wingspan, and because of that, it also can handle a lower mass payload. It will not be like possible that a 100 kg or more than type of payload can be there against the airship type of HAPS, which is lighter than air. It has a sufficient space or sufficient capability to have a massive payload capacity because of this larger surface area, even including or having a phased array antenna and all those things. So different platforms solve a different problem. It is nothing like any one is fix for or a best suit for the connectivity. Probably fixed wing may be more useful for the earth observation type of application or imaging, and airship type of HAPS may be better used for the connectivity solution where more payload it can be distant. Can we go to next slide, please? So in terms of the technology landscape, if we look at it, so HAPS not a new concept. From mid 90s, there have been a multiple studies going on in terms of the regulatory point of view. However, there have been a multiple tests in early 2000 by Europe and Japan. NASA has also experimented airship in stratosphere during the same time period. Then it started the second phase where big tech like Google and Facebook tried using HAPS as a connectivity solution, and that has given a very important and critical data which showed the promise. But during that time, because of the limited technology, it could not scale commercially. But now from the last 4-5 years, we have seen the momentum is building again, where SoftBank using like HAPS Mobile Sunglider, then Altos, then Sky are pushing multiple trial, and they have already shown the promise in terms of the technology point of view. So if we see what were the driving factor perhaps in the recent period, which is showing more promise, or it showing that yeah, of course, it's a viable connectivity solution. So if I need to divide in what are the major points. So one is the technology advancement. There has been multiple advancement in terms of the solar cell efficiency, advanced batteries, autonomous flight, AI enabled controlled systems, then improved weather model. Earlier even it was difficult to even model how the weather is going to behave, but now there is a better technology or solutions are available to model those. And then the advanced antenna system. Then once ITU has identified HIPS in terms of spectrum and regulation part, then it become a seamless type of connectivity which can give directly to mobile phone within that wide footprint of 100 to 200 kilometer. In terms of the regulatory point of view, WRC 23 was a trigger point where ITU had designated the specific radio frequency for HIPS, which can be directly used to connect a mobile phone using the MNO spectrum. And then the latest are recent real world testing, which has shown the successful trial. For example, Airbus, Schaefer, then SoftBank, HAPS Mobile, which has proved HAPS capability to deliver the broadband type of connectivity, not on paper, but in reality in the remote area and disaster zone. And the major findings were which has proved it will work for the filling the coverage gap. It works and provide the good throughput. It is also successful connected mobility. Backhaul connectivity has been tested, and because of the real test, the strong link budget has been verified, and the spectrum reuse within those 6-7 beam has also have been verified. So in terms of the trials point of view, it proves that yes, this technology is very good for the connectivity solution. But To make it commercially viable, I think it is important that how it is going to scale the capacity, how it can prove the economics where it can be adopted, this technology can be adopted by a telecom operator, and also how that mass production of those HAPS can be ensured. So in terms of, if we see where those 4 5 pillar stands, so performance has already been tested, payload power, station keeping, weather resilience has been tested, but a lot of improvement might be needed. And then the major important part is the mass production. For example, even to have a nationwide coverage in India, probably maybe 150 or 200 HAPS might be needed when even we want to cover the coastal region. So such a requirement whether can be met quickly. So one is the mass production, though in trial it has been tested, but how that can be improved is the point which I think industry need to look at it. Can we go to next slide, please? Yeah. So in terms of connectivity point of view, if we talk HAPS versus terrestrial or HAP versus satellite, so there are areas where terrestrial may not be much economically viable. For example, in uneven traffic, which gives the low return on investment, which is a limitation of cellular densification, because there adding the cellular tower may not be much of commercial viable. So many sites serve low density demand. Those probably can be best leverage using the HAPS technology. And even in fact, if we see in terms of the coverage point of view, so one HAPS coverage can be or equivalent to around maybe hundreds of macro cell base station. So it is so areas where there is not much population residing, but the connectivity is essential. So probably one HAPS can cover equivalent to 100 base station. This is how HAPS can play a major role for connectivity. When we compare this with the satellite, so due to the physics and technical reason, due to the short path, HAPS offer better link margin, low latency, seamless high throughput to mobile compared to satellite, unlike like low bandwidth services, which is possible today by using satellite D2D. So better economics for country specific or regional coverage. So HAPS, as we know, in terms of the characteristic, it may not be like a global coverage. So HAPS would be ideal for covering the small dense region. Like even in each country, there may be a pocket where HAPS will serve as a filling the gap. In terms of the satellite, be it LEO, MEO, or GEO, it is ideal for covering vast region with sparse population with the low data rate type of requirement. So HAPS and satellite probably together can work and complement each other, where uh, HAPS can be form a layered structure where it works as an access layer, where it directly connect to the user equipment, where satellite can play as a backhaul to connect the gateway and then connect to the HAPS, as shown in the diagram. Can we go to the next slide, please? Yeah. In terms of the spectrum and regulatory, it's very important to know that WRC 23 was a big breakthrough, perhaps. Though there was a lot of trial and testing, but there was not a certain spectrum available for the HIPS. So WRC 23 has recognized a service link spectrum starting from 700 megahertz to 2.6 gigahertz. For example, in India, if we see in the footnote is already there are I think 60 megahertz spectrum available in sub gigahertz band, and then in mid band as well as 2.5 to 2.6 gigahertz there are sufficient spectrum identified for the HIPS, though there are some restriction in terms of the direction, like there are few bands which is limited for reception, then there are few for transmission, but still I think there are sufficient spectrum available, where the in terms of the regulatory and the spectrum point of view, I don't see there is going to be a challenge with respect to the service link. In terms of feeder link, I think long back a portion of spectrum has been identified for the feeder link, starting from the C band up to Q and V band. But the important point to note here is in the region 3, including India, all those spectrums are available only in wave. For example, in C band, there are only 5 countries in region 3, where India is not a part of that. So one point which we need to understand, these feeder links, when they are going to use this wave, how how important is to ensure that 100% availability. So that is the one point which we need to consider, whether at each backhaul there has to be a diversity site, so that the link availability is better, because during rain these wave behaves a high attenuation, maybe 20 to 25 dB, though it has a lot of margin because of the distance, but we need to look at it in a practical scenario or during testing how it is going to behave. So that's one point we need to consider. In terms of the regulation point of view, as I already mentioned, that for user link already the IMT spectrum is available for HIPS. And for India perspective, NFAP has already recognized those frequency for HIPS services. And in terms of the local rules regulation, it is similar to like local MNO network, where it is going to connect to MNO core network and will comply all the local rules. The one open point which probably is important to understand, that how the regulatory landscape is currently with respect to aviation risk, since these are at 20 kilometer, but during the descent phase, uh, uh, to avoid any mid-air collision, what are the rules regulation to be followed? That's one point which need to be discussed with DGCA as well as the aviation areas. Can we go to next slide, please? So in terms of the challenges, so if I need to divide, which need is still lot of activity to be done, though all those test trial has been done, but in terms of the regulatory point of view, as my previous colleague has already highlighted a little bit about that interference and coexistence. So one point we need to understand here, since the coverage is around 100 to 200 kilometers, so there would be some spillage to the neighboring country, and how to handle those things. Probably ITU has already identified in terms of the PFD limit, which of course is going to help. But even to avoid interference to the HAPS reception, which will be from the ground, where multiple UE will be transmitting, and when there, since because this is the 100-kilometer means a lot of UE would be transmitting. So how those part will be handled is one point technically we need to look at it. And then the strict PFD limit is going to play any role in terms of the throughput to protect the IMT as well as other primary services. And as I already mentioned, the development of traffic management with respect to the aviation regulation is a another point which need attention. In terms of the technical or engineering point of view, if we see, so in with respect to like size, weight, and power and cost, these are four very critical uh, points for any commercial viability. Then the in terms of the maintaining platform overnight, so require probably sufficient battery density, because there will not be any direction available during that time. So those testing and reliability need to be verified, so have to ensure that yeah, it has a long endurance. Then other points is the thermal management between the day and night. So these are the few technical aspects, though it has been in terms of the trial and testing, it has been done. But to ensure the reliability and long endurance, I think probably these are the few points which still need attention. So beside those regulatory and technical aspects, commercial success is very important for HAPS, and that is going to depend on economics and high reliable aerodynamics. Though these technical point are those regulatory point may be addressed, but actually how it is aerodynamically going to behave in the stratosphere is one point. And second is what is the deployment cost as well as the management cost during that period is also going to probably show that how HAPS is going to work in future for connectivity. Can we go to next slide, please? In terms of India perspective, if we see, so in my view, HAPS is very important layer for connectivity as an integrated NTN and TN strategy. And when we talk about India, which has a difficult terrain, border areas, huge border region, connectivity lag in the northeast region, islands, there are multiple unconnected highways or long distance. Then the coastal connectivity, disaster management, include even in universal service, which makes HAPS a critical layer of connectivity in India. And to meet or to bring those HAPS in a commercial viability, what I feel is, in my view, what I suggest is we need to have a launch a national HAPS test bed, which will test those regulatory and technical analysis. Then we should also enable some experimental spectrum access to test those. And we need to quickly align DOT and DGCA for those open point in terms of regulatory framework, importantly in the aviation sector. And I think HAPS also should be integrated into the Bharat 6G vision, which is a agency in India which is working for the 6G, so that it timely integrated with the overall connectivity perspective, and then develop the interoperability standard with the satellite NTN as well. Can we go next slide? I think this is the last slide, probably. And yeah, so there are few takeaway in my perspective with respect to HAPS. So HAPS is technically feasible and has a real future, which has been already verified by the test trials. Now technology is transitioning from the demonstration to the operational deployment, as my previous colleague Sakata has already mentioned. In Japan, it is going to have now pre-commercial level. Then the economics and reliable aerodynamics is going to determine the commercial success, because this is one area which today clearly not coming out properly, what is going to be economics and how it is going to behave for longer duration in the stratosphere layer. And it is very clear that future is not a single connectivity, it is a intelligently integrated terrestrial plus HAPS plus satellite. It's not any one technology. And HAPS is going to play a middle layer of connectivity. And the countries which are going to establish or enabling regulatory framework quickly and doing the early deployment are probably going to gain strategic advantage in the coming or emerging NTN market. So overall, if you see the key messages, technology readiness is approaching commercial readiness now, but sustainable business model is going to depend on these points in terms of, like, as I mentioned, reliability and economics. These are the open points and key challenges, which is going to define how HAPS is going to work as a connectivity network. Thank you. Thank you so much. If any question, I can take at the end.
Thank you, Prafulla. I guess it was a very nice talk where you touched upon a lot of aspects. And a very distinct factor that you brought out is about the possible shortcomings, if I can say, from the commercial point of view, right? So as we have seen in the previous keynotes, there are a lot of trials, and the technical readiness has been mentioned. But what may drive very importantly for commercial success is the economics around it, which you rightly brought it out. I think that is very important aspect for to see the HAPS or HIPS the commercially very viable solution. Also, you brought out very strongly about the perspective from India point of view, as you mentioned that it is one of the important layer in the telecommunication as far as India is concerned. And you also brought out some suggestions how we can leverage or bring out this particular technology, and how do we do some initial efforts to make this also one of the important pillar in our telecom sector. Thank you very much, Prafulla. So what this particular discussions keynotes brings us is that we need to have some more discussion on how or maybe some exchanges across. So what I would so as we plan, we will go for a panel discussion, and I would request my colleague Mr. Suresh, where we will have some discussion with our keynotes plus some more speakers going ahead on the same matter. So Suresh, over to you. We can go for a panel discussion. Thank you, Prafulla, and thank you very much.
Thanks.
Thank you, Abhijit. Thanks for the wonderful session to all the speakers, and good evening to the participants present here. We had key insights on how the HAPS is going to rule the next generation communication, especially in the 6G architecture, and how important is in the multi-layer next generation communication. As in any new technology, we definitely have more open points to discuss. And with the eminent panelists here, we will take through those questions. And I also encourage the participants present here to post their questions in the Q&A. We'll take them at the end. And now over to Prof. Tim. If we can bring up his bio. Yes. Prof. Timothy O'Farrell is a chair professor in wireless communication at University of Sheffield, UK. He has extensive research expertise, especially in the waveform, and we love to bring his view on how the waveform is critical in structuring the HAPS technology, as well as what are the possible waveforms that is more prominent in the next generation communication. Over to you, Prof. Tim.
Thank you very much, Suresh. Can you hear me okay?
Yes, you're loud and clear.
Okay, thank you. Let me share my screen. Okay, if you want to share my presentation, please go ahead. So thank you to the organizers for inviting me to this event. I'm very pleased to be here. And able to talk about some of the recent work I've been doing on waveforms, which have been presented at the 3GPP 6G radio standardization process since last September up to the current, and we'll be continuing forward. All I want to do here, very short presentation, which just puts the waveform context into HAPS. So yes, please, next slide. Very briefly, I think we've seen from our other distinguished speakers their excellent presentations, the way they've pointed out the distinctive nature of the HAPS channel. So just to emphasize, we're looking at something which is a large cell footprint, perhaps from 50 to 200 kilometers on the ground surface itself. That this is characterized in terms of the channel also by a fairly long coherence time. This is due to the relatively slow motion of the HAPS platform. Often we see line of sight or a quasi line of sight, which helps the quality of communication by having a strong dominant path. And also there's a moderate Doppler shift in that sense. And the moderate Doppler shift tends to mean that we don't have too much Doppler spread, and it's not too challenging for the waveform. But there are points which we need to take into account. And part of that is shown below in terms of why this matters. In the case of HAPS, there's a lot of elevation-dependent path loss. So you do get a near-far disparity across the footprint, and together with the long coherence time, when you look at this from a 5G or a 6G perspective, then you need to work out things like the CP length, cyclic prefix, the density of pilots, and so forth. So all of that matters quite a bit. So if we move to the next slide, what we've seen in the 6G waveform discussions, in many ways, very early on, there was a decision to establish a baseline for the sake of the economics largely. And so the baseline very much wanted to stay with the OFDM waveform, CPOFDM on the downlink, and CPOFDM, DFTS, OFDM on the uplink. And in terms of those choices, there were alternative waveforms on the table. OTFS was one of the protagonists, AFDM, and our own waveform, which has been developed at the University of Sheffield. I call it OSDM, orthogonal sequence division multiplexing, and that is an OFDM related waveform in itself. So it's not a CDMA waveform, it's actually aligned with the OFDM basis. And all of these waveforms, the focus was really on the terrestrial network. And so the choice of the waveform is much more driven by the needs of the terrestrial network. And consideration to the NTN, the non-terrestrial network, is predominantly in the satellite section. And to the best of my knowledge, I don't think there is a specific 6G standardization activity about HAPS. So I think the HAPS position is to inherit a lot of the outcome for the NTN side. But that said, clearly, as we've heard today, HAPS has a very distinct environment and a very distinct platform. And that lends itself both to the terrestrial solution and the non-terrestrial. And some of the key requirements refer to the delayed Doppler resilience, low peak to average power ratio, because actually for HAPS, this is important in the downlink as much as the uplink, whereas terrestrial, it's mainly an uplink problem. Strong interest in low channel estimation complexities. And of course, one of the potential big service or markets that HAPS could make significant use of is the integrated sensing and communication support, so the ISAC support. So I've produced a very brief table there which compares OFDM, OTFS, and OSDM in terms of Doppler robustness, PAPR, equalization, standards maturity. And for us, OSDM, we feel we've got things which go beyond OFDM in terms of a better PAPR controllable scenario, a similar low complexity in terms of equalization, and the ability to map to high order MIMO, both in the uplink and the downlink. But like OTFS, we're an emerging waveform, and we're quite pleased to one extent with the outcome of these early decisions of OFDM being a baseline, because that doesn't close the door to further OFDM-based waveform development, which can bring benefits to specific environments, and OSDM is very much in that scenario. So if we move to the next slide, slide 4. Okay, so PAPR reduction, this is very important. We can contribute to that argument with OSDM. Tends to be specifically bandwidth specific. The narrower the bandwidth, we can contribute a lot. Our channel estimation is actually simpler than the 5G new radio. This is quite a big advantage, and we can support larger than rank 1 uplinks and downlinks. And OSDM is a native ISAC waveform. So you don't need to do anything separate between the sensing activity and the communication activity. So let me round off on the next slide, slide 5. we're quite interested in the HAPS platform and technology. I think there's a distinction between 6G standardization, which is NTN, TN focused, but the 6G vision, for which HAPS very much fits in there as the 3D network. And so depending on the markets and the use cases, I'd be quite confident we see HAPS. What we feel altogether, HAPS occupies a distinctive channel regime. We do feel that more models are needed for that particular channel so that we can optimize waveforms. While OFDM remains the pragmatic near-term baseline, new waveforms which are OFDM based can bring enhancements, and those studies are likely to continue. Sparse, line of sight aware, channel estimation, native IS supports, they're natural fits to the HAPS platform and particular vantage points that we would see developing. Standardization, as I mentioned, still very much in the formation side, very NTN specific in relation to HAPS. But I think one of the key points, which does come through from recent standardization discussions, is the need to extend TDD to HAPS platforms. And that would really make it easy for the interaction with the terrestrial network, as well as with the satellite network. So I think that's something to watch on the standard side. So I'll finish there. Thank you very much for listening, and happy to join in with the discussion and the questions. Thank you.
Thank you, Prof. Tim, for giving an enriching overview about the possible candidate waveforms. Definitely, with the unique capabilities of the HAPS, the same waveform cannot match the performance as in the terrestrial networks. Thank you. And
Thank you.
To continue and steer the discussion, I would request the panelists to set the context briefly and explain what would be the single biggest opportunity for HAPS in the 6G market, as well as what do you see as the single biggest challenge to deploy these HAPS at scale. I'm sure you would have addressed these in the keynotes, but to name one biggest challenge and one biggest opportunity, I would request to start from Dr. Kent, please.
Yes, I'd like to explain my views on the challenge, the big challenge of HAPS. So from my perspective, one of the big challenge from the technology perspective is how to keep the HAPS in the stratosphere for a long period, because this requires further technology enhancement, such as solar panel energy and lightweight and durable airframe of HAPS. So this is why we select the initially the lighter than the air platform for our pre-commercial service. This is advantage is long duration for that operation. And another biggest challenge is ecosystem development and global awareness. So as everyone knows, compared with LEO satellite direct to device, HAPS is still less widely recognized, and the number of the activity player is still limited. So we need to build a cross-industry HAPS ecosystem and promote HAPS globally. And this is why we established the HAPS Alliance and have been working to increase the presence of HAPS in standardization activities such as ITUR and 3GPP, and also seamless like this TTDD event are very important because sharing our activities, including SoftBank and experience and insights, can help accelerate global understanding and ecosystem development. So if we are gathering the idea, we can get opportunity to wide HAPS ecosystem business among the globally. So this is we think this is a very big chance, such a good conversation discussion. Thank you very much.
Thank you, Kent. for this insights. Prof. Animesh, your views, please.
Yeah, to me, I feel that HAPS like it has a lot of potential, and the thing that is blocking them is regulatory compliances that we need to discuss with all the federal governments. That is one thing, and second is from the technical point of view, I feel that HAPS will be handling a large scale network, and the large scale network handling large scale network is very difficult. So we have to find out ways, uh, technical solutions that can solve such a large network and very low latency, because larger the network, large time it will take to find us, infer the solution. So we have to, bring AI and optimization and quantum computing type of, solutions that can solve these things in low latency, very, rapid solutions. Thank you.
Got it, Prof. Got it. I would like to move on with Mr. Prafula.
Yeah, thank you. Thanks, Sushan. So before bringing challenge, probably I would like to highlight one major advantage of HAPS, and which I clearly see to have coverage in the border region and maybe rural broadband directly connecting to device, which probably satellite can do, but not for the all the use cases. So this is where I see HAPS is going to play a major role. Now coming to the challenge part, probably in my point of view, I would not separate here regulatory and technical, because for me, both must progress together. And if I see challenge, so both have a challenge. For example, technology without enabling regulatory framework cannot scale. And similarly, while regulation without mature technology cannot deliver the commercial outcome. So basically, these are the two areas which I think required the major focus for HAPS to make a commercial viable connectivity solution for everyone. This is what I feel.
Thanks, Prafula. Rightly pointed, both has to go hand in hand. And we already have few trials which is conducted by SoftBank. I'd like to get your opinion, Mr. Kent. As you have did multiple trials and moving towards the commercialization, I congratulate SoftBank as well as what do you think you can share as a learning based on your trials, and what were the surprises that you had during your trials?
Yes, thank you. I'll highlight three learnings. First, technically, our trials showed that HAP can provide rich communication services from the stratosphere similar to the ground-based station, including a video call and broadband-like applications. So this is a very good business chance by the HAPs. And second, operationally, we learned that different platform types have different strengths. And during the presentation, someone mentioned, because HEA may be strong for maintaining position over target area, while LTA may be strong for long duration trusted operation. So the different platforms is depending on the different usage scenarios. Third, from a regulatory perspective, we learned that the spectrum regulation needs a long-term strategy. For example, WC23 identified for HAPS service link bands in the radio regulation, but it took around 6 years from the agenda setting to the revision of radio regulation. So technology, operation, and regulation will need to move forward together and with a very good plan by the MNO and the government. Thank you.
Yes, thanks, Kent, and definitely your role here is quite well. And I'd like to move on to Mr. Prafula. On the deployments, and as you rightly pointed out, not just the technology, there is a lot of economics involved from the operator's point of view, what evidence do you look to move from the trial stage to considering HAPS as a integral part of the 6G network? You can throw the operator's point of view.
Yeah, thanks, Suresh. But yeah, before coming to direct to answer, so I would like to highlight as an operator, uh, we don't see HAPS as another network competing with terrestrial or satellite. Okay, we see this as a complementary layer in an probably integrated multi-layer connectivity for 5G advancement or 6G connectivity. So here the point is not whether HAPS is technically feasible. Rather, we should think that whether HAPS create a measurable value compared to terrestrial or satellite. So if I need to consider in my mind there are 4 or 5 points which I would like to highlight, which makes HAPS compelling for a operator point of view. Point number one is seamless integration with existing 5G or 6G architecture, which will allow HAPS to function as probably another RAN layer with the standard 3GPP interfaces. So that's one point. Then, as I mentioned in my presentation about the competitive economics, right? Particularly at a lower cost of ownership than deploying a fiber or dense terrestrial infrastructure in the difficult terrain, where probably we may not have a much customer or much services to connect. Probably that's the another way up to look at it. And third point, as I mentioned about the reliability. So HAPS today, though, has been tested, but sustained platform endurance, then predictable availability in terms of the quality of service as well as the real availability to provide the carrier grade service performance is the another point which need to be certain before implementing it by any terrestrial operator. And of course, there are clear use cases, specifically in India, considering the disaster recovery, temporary capacity augmentation. For example, in some place there is a cricket match or something going on, and immediate capacity is needed. So it may not be feasible to have a one tower installed, though there are cow and other things. But of course, HAPS will serve such requirement as well. Then the remote enterprise connectivity. So ultimately, operators adopt a technology that improve customer experience. And if yes, HAPS is doing, then of course this is the another technology which definitely would like to leverage it. Thank you.
Thank you, Professor. Rightly pointed as the value is what you see in the technology, not the technology maturity. And I would like to move to Prof. Animesh. As you are working in all the three layers, and I hear about the challenges that is coming in, either be it the technical, regulatory, or the ecosystems. Do you see the similar challenges given the strict requirements from the INT 2030? Do you see similar challenges in the other layers? Uh, Satellite is one emerging. So do you see how mature the other layers are?
I think, of course, like, satellite and terrestrial network, they are, already have their own, technology, and HAPS is the one which is coming up. But combining all these three, which is the main issue right now here, like giving them, orchestrating them all together is the main issue, which I feel that because when we combine them together, so the issues like efficient handover, when changing the network, so it should be very efficient, and there has to be like some AI based approaches so that they can able to do the seamless operations, and if there is an issue they can able to solve it at their own without any human intervention. So So I see the problem only in when we bring all together, not individually, you know.
Okay, thank you, Prof. That's the key part because all the three has to work integral and they has to be
Right.
integrated.
Yeah.
Thank you for bringing that up. I'd like to move to Mr. Kent. As you were actively involved in the standardization activity of 3GPP and WPD, it is great that we brought in the resilience and extended connectivity as a key requirement for the IMT 2030. But do you think only this requirement will be a compelling case for the operators to see this as a permanent layer, or we need further stricter requirements in the IMT 2030?
Yeah, thank you. So regarding the resilience and the extended connectivity, yeah, this is a very aligned with the HAPS general concept, because HAPS can provide very wide coverage in the stratosphere and temporary development for the resilient network. However, we can also consider the other use cases and other requirements, such as Isaac, someone mentioned during the presentation. Isaac is also a good use case and requirement, such as autonomous driving, because HAPS is a very large area coverage, so it can be good to the rural area coverage for the autonomous driving. Such use case is also studied by Alliance industry entities rather than the ITR. So we should consider the very wide use case for HAPS, not only the requirement on ITR, but also another use cases communicate with other industries. Thank you.
Yes, thanks, Kent. Rightly pointed. There are many other use cases. That brings me to Prof. Tim. Do you think the same waveforms will outperform in both connectivity as well as integrated sensing and communication from HAPS? So how do you see the performances of OSDM or OFDM?
Yeah, okay, Suresh, thank you. It's a good question. At one level, you can kind of see that pretty much things are going to move forward with 5G type waveforms, and those waveforms are likely to be configurable sufficiently to cover all three areas: the terrestrial, the HAPS, and the NTN. It's probably the LEO in the NTN which is going to really stress this idea of one common waveform. And this is where OFDM could run into problems. So it's kind of being looked at the moment within a certain envelope of performance. But if LEO stretches that envelope, OFDM may run into problems. And so from that point of view, there is a lot of merit and a lot of interest in saying this should be a continual observation of how other waveforms, as much OFDM based, can meet those broader requirements. Because in many ways, given the cost of this technology, once deployed, you don't want to revisit these anytime soon. So there really does need to be a thought along the lines of just not sticking with OFDM, but being sensitive to how these network layers and the use cases identified here could be enhanced by enhancing the waveform. So I'm a very strong proponent of keeping that sort of corridor of investigation open. Release 21 might just have OFDM, but release 22 could bring in these further waveforms, building on that. And when you look at particularly HAPS, there's still a lot of kind of tweaking of the waveform, because it's not clear where the CP length should be. It's not clear how many pilots. It's not clear in terms of best cases of equalization, the channel models are not fully there to really answer all those questions. So there's still a bit of an open field in terms of not just research, but how to apply existing and evolving 5G, 6G technology to make sure that the use cases work really well. So yeah, so that's kind of some of the points I see on that. And mixed in again with that, is the Isaac case, which is another waveform. So we don't really want a separate sensing waveform from a communication waveform. This is something where integration really matters. And I think HAPS would benefit from that angle of a truly integrated waveform, making the seamless connectivity even better. Yeah, so those are some of my views.
Sure, Prof. Thank you. We see the OFTM staying for this release, but it will evolve based on the use cases. Thank
yes.
you. And I would like to take opinion from Prof. Animesh, as he pointed out the scale at which we are going to deploy these HAPS network or the end-to-end in the 3D layer is huge. And how do you see the AI, especially your work in the FLSTRA, how do you see that going to play a role in organizing or orchestrating these large-scale networks?
Yeah, so AI can be useful, to communication, and communication can be useful to AI. So, for example, apps, because of its position, it can, see lot many users. So, lot many users can be, get a, global machine learning model learned because of HAPS. But HAPS is also, using those, communicating with those users. So those users can also leave a kind of, some footprint about what kind of data they are, dealing with. Like, it could be, to slice the data types, So once HAPS can able to determine what kind of data, slicing is there, so that can also be used to provide, a resource allocation, efficient resource allocation. So, so if HAPS could able to learn based on those historical data and find out, what type of traffic is there, it can use and learn and able to give a very, appropriate ways for resource allocation type of thing. And also to, like it can also learn, channel also using these through learning. So this is about learning and using resources very efficiently, but also like when the users are just communication users, they're not going for global learning, but those users can be like allocated their resources very quickly. So we have a very one of our work we are right now we are working on this based on GNN, graph neural network, and we able to find out that like we saw the result that we could able to get let's say 500 users to be allocated with let's say 5 and 100 resource block in less than second time, using graph neural network. But on the other hand, when we use optimization based method to find out allocations, it takes more than 30 seconds or even more to so 30 seconds to find out the solution. So as the network will, because 500 is a very limited number, but as the network keeps on growing, so these number will certainly grow, and especially the optimization base will grow exponentially. So AI, I see that it's very useful here in getting these things done very quickly. To get the which user is going to get which resources.
Thanks, Prof. As you rightly pointed, the AI native is unavoidable in the next generation. and we
Right,
see
yeah.
a lot of multifold improvements in the network performance. Thank you. I would like to move to Mr. Kent. As you pointed, Japan has made your domestic regulatory frameworks. So if you could pass India a few lessons from the regulatory framework, where do you think, what do you think India can adopt from those frameworks to accelerate the adoption in India as well?
Yeah, thank you for the question. So the one lesson from Japan is the importance of a regulatory framework is align with the existing flexible framework for MNOs. And yeah, Japan's framework allows HAPS to be introduced as a high altitude base station within the existing mobile regulatory framework. So it's making it easier to utilize existing mobile spectrum license and assets and ecosystem capabilities. So this could be a useful reference for India and other countries when developing their domestic HAPS framework. So the MNO-friendly framework is very important for HAPS regulation. Thank you.
Thank you, Kent. I would like to follow up with another question on the interference. As you mentioned, the spectrum we are trying to retain the same as terrestrial. So how do you trying to mitigate the interference when you have a large footprint and they interfere with the terrestrial base stations operating in the same spectrum?
Yeah. For our payload for HAPS commercialization is mounted the phase array antenna, AS antenna. So HIPS can be controlled under beamforming to make an area. So if there are some existing base station direct to the antenna, we can use beamforming and control beamforming and beam steering to avoid the interference. So this is a mitigation technique we planned. And as someone mentioned that currently there other ITU radio radiation defines PFD limit for the existing services from HIPS to from HIPS interference. So administration and HIPS operator comply if administration and HIPS operator comply with such a regulation, interference from HIPS would not be unlikely to be a problem. And I'd also like to note that 3GPP also conducted a coexisting study between HIPS and terrestrial network in the same area in coexisting cases. This study shows that if HIPS comply with the ACALR requirement, same as the ground-based station, the sharing between HIPS and terrestrial network is feasible. So it is important to comply with the existing mobile network requirement for HIPS is very important to avoid the interference. Thank you.
Yeah, thanks, Kent. Definitely the way forward is to use the beamforming and null clearance so that we avoid those interferences. Thank you. Thank you. And with your permissions from the panelists, I would like to take questions from the audiences or participants. A few questions that I listed here is as Prof. Animesh or to the panelists, anyone can answer, please. As you pointed, there are FSO links between HAPS to HAPS for the inter-HAPS. How do you think it is effective to use FSO links for the feeder link?
Suresh, shall I take this?
Yes, please, Prof.
Okay. So I think HAPS to HAPS connecting optical link is a different than connecting from the ground. And as we know, optical links are very detrimental to any rain or any fog type of environmental condition. So identifying a suitable location on the ground to have a optical connectivity as a feeder link is totally different than having HAPS to HAPS, which is beyond the rain condition or something because it's above the cloud. So that is the major difference, having optical link between HAPS as well as on ground. Though there are multiple improvement in the tracking technology and all, but still it is not yet proven to have a 3-9 type of availability when you have a optical link from the ground. So yes, in future it might be possible based on the technology improvement, but currently it's a different than having inter-HAPS connectivity, rather having from ground as a backhaul for the optical link.
Sure. Thanks, Prafula, for your views. If any of the panelists has to add, please. Or I would like to move on. Yes, please, Prof. Animesh.
Yeah, so just in addition to the weather-related issues with FSO, also that affects both the HAPS to HAPS link and also HAPS to ground link is a drifting, which leads to pointing error. If the both HAPS are moving their position, so that is another issue which we need to care about while solving such issues. And of course, for weather-related issues, as Prafula has already mentioned rightly about the issue, but in that case, we can switch to RF-based, link. But however, RF link has lower capacity compared to FSO.
Yes, thanks, Prof, to bring that up. Definitely a dual link with IFSO and RF can be the optimal hybrid.
Suresh, I was just going to briefly comment. It is
sure,
a different,
yeah,
it's a different environment, say, compared with FSO between satellites. So the satellites move in a constellation. There's a lot of predictability in positioning. So it's more feasible, and you don't have those weather problems. But when you bring it back into the stratosphere and the stratosphere ground connections, as the other speakers mentioned, there's more variability to handle, which makes this FSO a little bit more challenging.
Got it, Prof. Got it. Thank you for your views. And there is another follow-up on the feeder links, especially. We see the standardization, especially only in the access link or the service link. How do you see the feeder link getting standardized, or everything is going to be proprietary going further? Any work on that? Please be open to answer.
I think feeder link is not based on the IMT technology, so we may not need the 3GPP standardization. So the feeder link technology is developed by the same as the current fixed link. So in my perspective, we don't need such a 3GPP specification for HAPS feeder link. Thanks.
Thank you, Kent. In the interest of time, definitely we have a lot of questions to answer, and I thank each of the panelists to take your time and answer these questions in detail. I have the list of all the questions that you have. I'll float it through the panelists and then get back the response later offline. I would like to pass it on to Mr. Abhijit to conclude with the concluding remarks. Thank you.
Thank you, Suresh. Yeah, it was a very wonderful discussion at the end of this session, right? So maybe now we are very close to end of our session. So I will take some moment to draw some conclusions on what we have discussed so far. So we began this discussion with the question that where we stand with respect to HAPS technology per se, and what are the premises where the HAPS based services or HAPS layer as such will bring the value for the telecom services. So we had a very great discussions, keynotes, where I guess almost all the keynote speakers has brought out the point that the HAP or HIP-based technology or the network will be complementary rather than a competitor to the services provided by terrestrial and non-terrestrial network. And also we discussed about the challenges, mainly from the technology as well as the regulatory point of view. It was very clearly brought to the notice that the challenges from the technical as well as the regulatory should go hand in hand, because they complement each other for ultimate success of a new layer that being discussed in terms of a stratospheric network, which is HAPS. We touch upon a lot of technical trials and the possibilities from the platform front. Also, we touched upon the difficulties related to the energy management, payload, and also regulatory aspects from the access as well as the feeder link perspective. There are some good news about the regulatory aspects, but there are some things which I guess been brought out related to the coordination between the aviation industry and the regulations around the HAPS. In a panel discussion, I guess we dive into a lot of interesting discussions related to the use cases, the possible the business model. Ultimately, what matters at the end of the day is how commercially viable the new technology that we are discussing. So I guess a lot of interesting points are brought out. If we want to take a single takeaway from this discussion, is that that integration, so the HAPS will be an integrated part of a terrestrial and satellite network, which I think it is rightly pointed out is as another layer which operators may think based on the use case, which makes this particular layer interesting. And there is good scope for interdisciplinary coordination between different industries like payload partners as well as the telecommunication industries, which has been happening. Also, the regulatory framework should go very, very strongly along with it. So with this, my sincere thanks. I would like to thank our keynote speakers and panelists for their very generous and generous discussion and expertise that they brought out. I thank the organization committee of TTDD event. And also I would like to thank for the audience for your attention and the questions, and for very good engagements. I think a lot of questions were asked. Some of the questions I guess our speakers have answered. But as I discussed, as Suresh mentioned, we can consolidate and then we can share with speakers for more answers. So I encourage to continue these conversations in possible form after this session. So thank you very much. Thank you all for a great session. Thank you very much.
Announcement here, and let me share my screen. Mic is not on.
Screen is not seen.
Mic is on.
Mic is on.
So Vaishali, your mic is on, but I think screen you have to share. Yeah, we can see your screen now.
So thank you, Abhijit sir, for your inspiring concluding remarks. Before we conclude, we kindly request all participants to share their valuable feedback on today's session. Your feedback is extremely important to us and will help us further enhance future editions of the TTD conference. You may submit your feedback by clicking on the feedback link shared in the chat window, or you simply scanning the QR code displayed on your screen. We sincerely appreciate you taking a few moments to share your thoughts. Thank you once again for your enthusiastic participation and engagement throughout the session. We warmly invite you to join us tomorrow for another exciting day of TDD 2026, featuring the following technical sessions. Session 5 will be on priority verticals and transformative use cases in 6G, which is from 2 p.m. to 4:15 p.m. in afternoon. And followed by session 6 is on open and interoperable systems for seamless connectivity of heterogeneous networks, which is from 4:30 p.m. to 6:45 p.m. in the evening. So have a wonderful conference experience, and we look forward to your continued participation. Thank you. And I request you all to switch on your videos to take a screenshot. Thank you, everyone.
Thank you. Thank you all. It was
Thank
very
you.
exciting talk.
Thank you all.
Thank
Yeah,
you for
thank
your
you,
time.
everyone. Thank you.
Thank you. Bye.
Bye.
Bye now.
Bye.